In this video, we are going to be looking at top 10 key facts you should know when trying to graph a linear inequality. Remember, when we talk about lines, we are looking at the slope intercept from y is equal to mx plus b for most parts. Inequalities do have or are associated with symbols such as less than, greater than, less or equal to, or greater or equal to. Less or equal to also have vocabulary such as at most or maximum, and then greater or equal to have at least or minimum. On the number line, when you need to graph inequalities, greater and less do have an open circle that starts from the boundary point. And then the greater or equal to or the less or equal to have a closed circle. The greater will move to your right and the lesser will move to the left direction. Boundary lines. So you do have the boundary line in terms of y is equal to mx plus b. And when you have less or greater, the boundary line tends to be a dashed line. That means to say any point on the dashed line is not part of the solution. And then when you have less or equal to or greater or equal to, the boundary line is a bold line. Shading the region. When you have y is greater than mx plus b or y is greater or equal to mx plus b, the shading will be on top. And then when you have y is less or equal to mx plus b, the shading is below. This is very, very important when graphing. So the shading and the boundary line. So we look at an example here and looking at the steps that is required. So in order to graph, we first will do step one where we build the line using the slope and the y-intercept. And then we graph the line, deciding whether it's solid or dotted. And then we fill in the shaded region and identify the solution set. So the solution set, if you have a dotted line, any point on the line is not part of the solution set. Test point. You can use a test point, usually 0, 0, if it is not on the boundary line to check which line should be shaded. So you substitute the coordinates of the test point into the inequality to determine if it satisfies the inequality. And an example is shown here to understand how to test to see where the shading will be using the points 0, 0. So example is given here, 3x plus y is equals to negative 6. You draw a solid line and then you test the point. So try 0, 0. And after putting that in, you realize that 0 is less or equal to negative 6, which is false. And then when you look at it, you realize it's actually false as well. So graphing systems of inequalities. For systems of inequalities, you graph each inequality on the same coordinates plane. The solution is the overlapping region of both shading. Now, you need to also remember that if the shading is on a dotted line, that is not true. The shading, if the shading is on the bold line, demarcating the overlapping region, then it is a true solution. So step one, you isolate y in each inequality if necessary. You graph in each inequality on the coordinate plane, and you identify the solution set. Inequalities and quadrants. Graphing inequalities can restrict solutions to a specific quadrant of the coordinate plane. That happens every now and then, and it depends on the boundary line, slope, and the shaded region. Linear inequalities. The graph of a linear inequalities produce a half plane. The boundary line divides the coordinate plane into two halves, one representing the solution and the other representing the area which is not part of the solution. So an example is shown here, the step that is required and the drawing, and you realize there are two half planes, the shaded portion and the non-shaded portion. Vertical and horizontal lines. So inequalities involving vertical and horizontal lines, when you have a vertical line, if it is greater than, then the shading will be onto your right, and if it is less than, it will be onto your left. When you have horizontal lines, then it is going to be above for greater and below for the lesser. And an example is shown. So we have y is greater than 4, and that is shown with a dotted line and shading above. And another example is shown concerning vertical lines, and you have x is less or equal to 2, and you can also see that the shading is on your left with also a bold line. No exact points for less or greater. Now, for straight inequalities, where we have greater or less, the points on the solution on the boundary line are not included in the solution. That is why we have a dashed line that is used. Applications in real world life situations. So graphing inequalities is used in and around us all the time, and it's used in various fields such as business, very, very important, how to optimize profit. It's used in engineering for feasibility studies, and it's used in a whole wide of things to make decision making in order to